You have an input value, you square the input value, that becomes positive, no matter what you put in. Positive times 4 is positive, add 1, that's positive. Is there any way to cancel out the 1 here? No. So our conclusion is there are no vertical asymptotes. This can't equal 0, so we have no vertical asymptotes. Okay, what about horizontal asymptotes? What do we do there? Take the limit, yes. Okay. Now, taking the limit of that, I'm going to pause this for a moment, let you guys have some time to... Okay. So
then you're left with like 3x, it's roughly equal to 3x over square root 4x squared. And then that gives you 3x over 2x.
So, you know, just to reiterate for the sake of the recording, you're saying that the 1 is going to become insignificant.
Yeah.
Okay. So that would be the same thing as the limit as x goes to infinity of 3x divided by, you said 2x, taking the principal square root of that, okay, which would then be 3 halves. And again, assuming the principal square root, okay, so we have to go back and say, well, it really could be either one, and that's how you get that, okay? Everyone follow the intuitive idea? Analytically, what can we do, though? Because maybe it's not, maybe it's got one of those little twists to it. We need to think about that. Anyone have an idea of what we could do to use one of those processes that we were talking about? Yeah, Emma?
I know I didn't agree. I should get times 1 over the square root of x squared, because the square root of x squared is still x, and then came up with the same answer.
Okay, so if we divide it or multiply it by 1 using that idea that Emma gave us, okay, so then this would be, okay, 3x divided by the square root of x squared, divided by, okay, I'm going to do it this way first for those who might need to see that step, because what Emma's then saying is that if you have the quotient of 2 radicals, it's the radical of the quotient. Okay, I can combine this under 1 square root. And at the same time, 3x divided by square root of x squared is going to be 3x divided by x, which would be 3. And down here, I would have the square root of 4 plus 1 divided by x squared. Okay, now again, we got to keep in mind, we got some pluses and minuses going in here. Okay, and so now if I look at that theorem 4.10, when we started off with in this section, what would be the limit of 1 divided by x squared? 0. So I have plus or minus 3 divided by the square root of 4, which is 2. There it is. There's my horizontal asymptote. Okay, so intuitively, graphically, and analytically, we agree. Something is happening there. Okay, so that's just the first part. That's looking at the asymptotes. So now we have an idea about that. Let's look at the extrema on this. Okay, so now how am I going to go about looking at extrema? Okay, so we'll just put up here so we know what we're doing. We're looking for extrema. Okay, so I need to take the first derivative. What rule am I going to use? Looking at the quotient rule, do I have any other rule I have to consider? Chain rule in that denominator. So I've got denominator. I found out on some of your quizzes that some of you are not showing me all of the lines of intent, and it really makes it more difficult for me to grade and to give you partial credit if I can't determine what you've done. So I just, for your benefit, hope that you will go back and add this line in, because without it, you can get really lost. And some of you are reluctant to do that for the chain rule, but it is important that you and show me what you intend to do with that. Some of you include it up here, and that's fine. Some of you put it all in one line. That's fine, as long as you show me what it is that you are looking at. Yeah, do I have something up there I need to check?
Again, the first and second one, right now, the solid units for its plus one for negative one. I'm going to find out.
Here? I don't think so. That's my denominator. If I, according to the quotient rule, it's the denominator as I see it. Okay. Now, if I want to do what you're doing, I would actually bring it up and write it as 3x the quantity, this to the negative 1/2. Then I would use the product rule. Either way is correct. Taking the derivatives are not going to be as easy as in Chapter 3, I can tell you, especially when it gets down to trying to work or to simplify them. Okay, without continuing on to simplify this any further, can we accomplish what we need to accomplish? After we take the derivative, then we do what? Okay, so now we'll say step number 2, determine zeros of the first derivative. Okay, of that fraction, what's the only piece that's important to me? Yeah, is the numerator? Numerator, yes. And so this is going to be maybe now I'm setting it equal to 0. At the same time, I'm bringing one of the terms across, adding it to both sides. That's how I'm getting this. What's that tell me? Okay, no critical numbers of the function, therefore no extrema. Okay, and the problem said label any extrema and or. So let's jump to the graph. Do we believe it? Do we make a mistake? I've never rule out the possibility that I've made an error somewhere. It's always possible. So the question is there an extrema here? Does this go up and then back down? If it does, we would have a critical number. It doesn't. So it makes me believe that no, in fact, I don't. And there's all other kinds of things you can do. Analyze the graph. If you analyze the graph and you want to look for a maximum, set that, and from where I went, this is the end point of where I went. Okay, let me go back and do that again for you. If I analyze the graph, you got to be real careful with this. I said find me the maximum between an input here and an input here, or here. Or notice where that maximum is being stated? Exactly where I have my... So there is no maximum on that. And have we verified that with our derivative work? Yeah. Hannah, you see something there? I mean, Jenna? Now, if we took the second derivative of this, and the reason I really don't want to go there is that, does anyone really want to tackle this derivative? No. Okay. If I had a critical number, I would have to tackle it and, find out what the second derivative is and put those zeros into the second derivative, but I have no extrema, so I'm not going to bother with that. Okay. Let's go on. We have one last problem here. Oh, yeah. This idea. Logistic functions. You can write all you want there, but I'm going to just kind of block it out. I just want you to think about this for a moment here. There's the exponential function where, I tell Sadie a secret, and then we both turn around and tell two other people, and turn around and tell two other people, the 2 to the x power function there. That logistic function has a curve that will look like this. Actually, steeper than that. Let's see if I can draw it a little better here. Kind of like this. Okay? And it's going to continue and continue and continue, exploding in growth. How many times will it take for us to spread this rumor to 1 million people here on campus? There are not 1 million people on campus. Yeah, okay? There aren't 1 million people, so it's impossible. In fact, we can spread this rumor as fast as we want, but there's going to be a limit to how many people can actually know the limit, or know the rumor. A limit imposed by how many people are on campus. You know how, and we're getting to that Christmas season now, there's always going to be